Hello everyone, welcome back to my channel. As you all know, this is Shrujana graduating in Sri Venkateshwara College of Engineering, Bangalore, Semester 3, Section Brahmos, USN 1VE23 EC072, Subject Digital System Design using Verilog. Coming to the topic, Sequential Logic Design, Flip-flops and Latches. Introduction to Sequential Logic Design. Sequential logic design is a fundamental aspect of digital circuit design. It refers to circuits whose outputs depend not only on current inputs but also on past inputs. This is achieved through the use of storage elements like flip-flops and latches. This is an example of sequential circuit you can observe using the logic gates. What are latches? The latch is a basic storage device that holds a binary value. We know that the binary values are two, one is 0 and one is 1. It operates continuously, meaning its output can change also along as the enable signal is active. Latches are typically classified as level sensitive devices. A latch is a temporary storage device that has two stable states. By stable, it is a basic form of memory. The SR set reset latch is the most basic type. It can be constructed from NOR gate or NAND gate. With NOR gates, the latch responds to active high inputs. With NAND gate, it responds to active low inputs. Types of latches. The most common type of latches are SR, D, and JK latches. SR latches have two inputs, set and reset, and are used to store a single bit of data. D latches have a single data input and are designed to eliminate the indeterminate state found in SR latches. How latches work? Latches are controlled by an enable signal which determines if they should store or change their state. When the enable signal is active, the latch can accept new input. When inactive, it retains its current value. This behavior allows latches to function as temporary storage elements in digital designs. SR latches as shown in the figure. S are nothing but set and reset. What are flip-flops? A flip-flop is a more advanced storage device compared to a latch. Flip-flops are edge-sensitive devices, meaning they change their output only during specific transitions for the clock signal. They are widely used in synchronous circuits for reliable data storage and transfer. Latch and flip-flop. Input, output. The flip-flop is placed in the middle. Inputs are given at the right side and output is observed on the left side. This is how the waveforms are produced during the output and the input. Types of flip-flops. The primary types of flip-flops include D, JK, T, and SR flip-flops. D flip-flops store data on the rising or falling edge of the clock signal, making them popular in registers. JK flip-flops combine the functionality of SR and D flip-flops and can toggle their output state. This is T flip-flop and JK flip-flop, SR flip-flop, and D flip-flop. Where in the D flip-flop, the diode is used, and the T flip-flop, two AND gates and NAND gates are used. In the JK flip-flops, four NAND gates are used, where SR flip-flops and four NAND gates as well as the JK. How flip-flops work? Flip-flops capture input data on clock edges, ensuring synchronized data transfer. They have two stable states and can change state based on input conditions during clock transitions. This characteristics makes flip-flops essential for building memory elements and sequential circuits. This is how the flip-flop works. This is SR flip-flop, active high, set and reset are the inputs. These are grounded and these inputs are given to the NAND gates, which are connected sequentially, and the output is observed at the output side. Key differences between latches and flip-flops. The primary difference lies in the sensitivity to control signals. Latches and level sensitive, while flip-flop are edge sensitive. Latches can change output as long as the enable signal is active, while flip-flops only change in clock edges. These differences influence their applications in digital systems, particularly in timing and synchronization. Most of the times, SR latch is and the SR flip-flop are taken as the examples, and this is a truth table according to the output. Applications of flip-flops and latches. Both flip-flops and latches are used in memory devices and registers within microprocessors. They play a crucial role in data storage, state machines, and counters in various digital systems. Understanding their operation is essential for designing reliable digital circuits. Conclusion. Flip-flops and latches are foundational components of sequential logic gate. Their unique properties allow for effective data storage and manipulation in digital circuits. Mastery of these elements is vital for anyone working in electronics or computer engineering. And a sequential circuit consists of a feedback path and employs some memory elements. That is nothing but the combinational logic is have three inputs and external inputs, three outputs, where where the memory elements exhibits three outputs from taking to from taking through combinational logic block. So sequential circuit is equals to combinational circuit logic plus memory elements. Thank you. If you like my video, please like, share and subscribe.